Hi, today we're going to be tackling array problem set 2, number 6. The problem statement says find equilibrium index such that sum of elements at lower indices are equal to sum of elements at higher indices. Now, what does that mean? Well, if we're given an array of integers, this one specifically, -7, 1, 5, 2, -4, 3, and 0, we expect to get the index 3. That's because the sum of the elements at indices 0, 1, 2 equal -1, and the sum of indices 4, 5, and 6 equal -1 as well. So the lower indices here equal -1, the higher indices here equal -1. The midpoint between those two is 3. So that's our output. That's why we get 3. We're going to tackle this problem in ON time and O1 space. So let's take a look at our pseudocode. So what we're going to do is we are going to initialize two variables that are called left sum and right sum. We're going to initialize them both to 0. Left sum equals 0. Right sum equals 0. Okay. And then what we're going to do is we're going to assign our right sum to be the summation of all the elements. So we're going to say array, we're going to reduce it, JavaScript style. We're going to return A plus B, which will return to us all of the elements summed together. Okay. So if we were to sum all of this up, I believe this should give us 0. Should give us 0. So it's -7 plus 1 is -6. -6 plus 5 is -1. -1 plus 2 is 1. 1 plus -4 is -3. -3 plus 3 is 0. 0 plus 0 is 0. So right sum should be 0 right now. Then the next step we're going to do is we're going to loop through this array, and we're going to subtract each one of these elements from the right sum. So let's do a regular for loop. For let I equals 0, I less than array length I plus plus. So we're going to reassign the right sum to be equal to minus equal the current element. So the first run around, when we take away -7 from 0, take 0 minus -7, that'll get us 7. Then we ask, is 7 equal to 0? Because we're going to ask, is the right sum equal to the left sum? If it is, we're going to return the current index. If it's not, then we're just going to add the current element, -7, to our left sum. And that's how we're going to do this in ON time. Okay, so if right sum is truly equal to the left sum, then we are just going to return the current index, which is called I. Else, we are just going to add the current element that we subtracted from the right side and add it to the left. So, first case we ask, is -7, or excuse me, is 7 equal to 0? No. So then we go back, so then we add -7 to left. So this will be -7. We go back to the right, and we subtract 1. We subtract 1 from 7, which then gives us 6. So it goes from 7 to 6. We ask, is 6 equal to -7? No, it's not. So then we add 1 to -7, which will give us -6. So then we go back up, we take away 5 from 6, which gives us 1. We ask, is 1 equal to negative 6? No, it's not, so we add that 5 onto negative 6, which gives us negative 1. Go back up, we take 1 minus 2, which gives us negative 1. And then we ask, is negative 1 equal to negative 1? It is, so then we return 3, and that solves this problem. If we were to be given something else that wasn't a passing case, such as 3, we would expect to get negative 1, which we indeed would. And that's how you solve this problem. Thank you.